is we have a question from example number 8 in 6B. I'm going to go over this real quick. Please stop me if there's a particular step that is confusing or if you need more explanation. So it says, use an algebraic method to find the polar form from 0 to 2 pi, not including 2 pi, for the complex number. Approximate exact values with a calculator when appropriate. Let's do A first. So for A, we're going to be using these two equations, which appear on the very first page. Let's see if I can find them for you. Right here. Okay. I wrote them here so that I wouldn't have to keep going back to the front page. So z is a plus bi. That means that a is 1 and b is negative root 3. And I know that r is the square root of a squared plus b squared. Using this information, I can find r. So I plug in 1 for a, negative root 3 for b, plug it in and solve, I get r equals 2. Good so far? Okay, now we need to figure out what theta is. So, keep in mind that this graph is not the polar axis, that we are graphing the real axis and the imaginary axis. But whatever axes you use, the angles are going to be the same, because the ratios are all going to be the same. So if we know that this is 1 here and negative root 3 down here, on the unit circle, that's going to be 5 pi over 3. Let me see if I can find a unit circle to pull up. Okay. So down here, this is 1 over 2, root 3 over 2. Remember, the unit circle has a radius of 1. If you extend it to 2, this is going to be 1 and negative root 3. You guys okay?
Yeah. I'm okay.
Sorry. Yes, I think. So what we're looking at is, if this is 1/2 and negative root 3 over 2, if you double that, it's going to have the same ratio. It's going to be the same angle. It's going to be longer, but at the same angle. Yeah. Exactly. Right. If the ratio is the same, the angle is going to be the same. If you multiply by 2, if you multiply by 3 or 4 or 10, the angle is going to be the same. It's just going to have a longer radius. Okay. Sure thing. Okay, so that's how we know that the angle is 5 pi over 3. I'm going to plug all that in to this equation, which is also in that same box, and I get this. This can be written this way in factored form, or this way in standard form. Since the bulk of the AP exam is multiple choice, be prepared for either form. So as you can see, a lot of these problems depend on you memorizing the formulas. So I'm really hoping that if this has a large presence on the AP exam, that they will provide you with those formulas. I know on the AP Calculus exam, there's very few formulas you're expected to memorize. I mean, you're expected to know, like, the quotient identities, the reciprocal identities, the Pythagorean theorem, the quadratic formula, the formulas that you've been using a lot. But formulas like these are really complex, and you only use them for very specific problems, so fingers crossed. I don't think they're going to have a big presence, but they might appear here and there. I saw a hand, but I didn't remember who had their hand up. Yes? Oh, yeah, I got you. This way? Oh, I see. Mm-hmm. Yeah, typically when you graph the real and imaginary, or like complex numbers, the real axis is like the horizontal axis and the imaginary axis is the vertical axis. But it's important that you know that this is not the XY axis. You're actually going, if you turn the XY axis horizontally, you're going above that in a different plane. People looked at me like, right there. The angles are all the same. That's what you need to know. Okay, so for B, it's the same idea. The only difference is this one does not appear on the unit circle. And so for that reason, we're going to have to use a calculator. We find R the same way. It's a nice 3, 4, 5 triangle. And then we have 4, 3, which is somewhere around here. So the way that I solved it, since this is the theta we're looking for, I solved for this theta, this I call theta prime, using tangent. And then I knew that whatever I get here, I'm just going to have to add pi to get the whole angle. So I solved this, I used inverse tangent, I got approximately 0.927. I saved that in my calculator, I didn't round. I added pi, and then I rounded. And then I ran out of space. So I continued up here. So I plugged it in here. This is the factored form, this is the standard form. Please remember not to round until the very last step. If you have big long decimals, store them in your calculator. Does anyone need a refresher on how to store numbers? Yes? Yes, I can. Sorry. Here? You're good? So this is all in the video that I emailed out yesterday. Yes? So we know that this is -3, -4. Because this is the real axis and the real number is -3. And this is the imaginary axis and the imaginary number is -4. So this is, I didn't label that. Okay. How are you guys feeling about this? Polar coordinates are fun, I think. But I'm going to be honest, I don't particularly like all the equations. But if you're given the equations, I think it's very doable. Hopefully if they have problems like this, they give you the equations. Okay. Does anyone need me to go back up here for anything? Are there any other questions on the 6B notes that I can help with? Okay, and if you didn't get a chance to watch the video, please watch the video. And if you have questions after watching the video, let me know. I'm happy to go back. All right. Yes. So I know on the calculator, there are certain formulas that you're just expected to know, like the Pythagorean theorem, the quadratic formula, certain identities like the Pythagorean identities, quotient, reciprocal. And then there are other formulas that are not necessary, but they're helpful. I probably, the sum and difference of sine and cosine is also a formula you're going to want to have memorized. But like the odd even, that one, it's not necessary to memorize as long as you understand which trig functions are even and which trig functions are odd. Then there's a bunch of other formulas that you only use for very specific problems. Those are formulas you use a lot, and so it's normal for them to expect you to know them. These formulas, I think the law of sines and law of cosines, I've been told are not required on the exam, but they're helpful. So it's one of those things that if you have space in your brain, go ahead and memorize it. I hesitate to say you don't need to memorize it because as soon as I say that, the exam writers are going to decide this is the year to have a lot of complex polar coordinates. But my gut tells me if they have complex polar coordinates, they're either going to provide the formulas or they're going to have problems that can be solved without having the formulas completely memorized. That's my gut. I think that you should know them. I think you should know how to use them because if there is one like this and they give you the formula, you should know how to use it. But I think beyond knowing that this is the real part, this is the imaginary part, and this is how you graph it, and these are the angles, that I think you should know. I don't think it's going to be super necessary. It might be one or two problems. Yes?
I think you said this already, but for the left side, how did you get
Left side.
5 and 3?
Oh, okay. So we know that we're going 1 here and -√3 here. And on the unit circle, that ratio exists. 1 -√3. This has a radius of 1. Ours has a radius of 2. That's why it's twice as long, and it's 1 negative root 3. Does that make sense? Yeah. Sure. Now the other one, that ratio does not exist on the unit circle. So you would use a calculator. So basically this one would be a no calculator problem, this one would be a calculator problem. Any other questions? All right, let's go on to 6C. More polar coordinates. Okay, so a bunch of equations, and I'm going to do one example of each one. So this says that when you have polar coordinates written in complex form, and you're finding the product or the quotient, this is what you're going to want to do. You're going to multiply the two r's, and then you're going to add the two thetas. If you're dividing, you're going to divide the two r's, and you're going to subtract the two thetas. And of course, this is when r2 is not equal to 0. So let's try an example of this one, and then I'll go back to De Moivre's theorem. Let me look up how to pronounce that. This is my year that I'm going to learn how to actually pronounce things. De Moivre's theorem. De Moivre's. I still can't pronounce it, even with the pronunciation. Okay. Use an algebraic method to express the product in standard form, then an algebraic method to express the quotient. Okay. And then I did not give you Z1, Z2. Here they are. And full disclosure, I didn't give you enough space. I'm so sorry. I went on to some Post-its down here. Feel free to write small, or feel free to go into the margins or onto a separate sheet of paper if you need to. Do you feel like you guys could use the formulas to solve this? So for this one, you would be using this formula. So this is R1 and R2. This is theta 1 and theta 2. You would just plug those numbers into the formula. What do you think? Let's try it. I think you guys got this. Please give me the product of these two numbers, write it in standard form, round to 3 decimal places. Yes, round to 3 decimal places. Yes, leave the I. Leave the I. So I is just going to be I. So you're going to give me decimal form. Sorry. Yes. Perfect. Yes. Correct. You guys are awesome.
Wait, listen, can I show you my paper? Because I don't have it.
Yes. Yes. Give me a second. Yeah, what I did is I put the whole thing in my calculator. I don't know what 25 is. So it should be a real number plus or minus an imaginary number. Hold on. Team 4 got it. Team 5 got it. Team 3, you said you got the same thing? Yeah. You're good. All good? You can use divide. Sorry, hold on. The first number is right. The second number isn't. I'm not sure. Sorry. Check to see, make sure your calculator's in radian mode. Okay. Yeah, the first number's right.
Wait, is it not sine pi divided by 12?
It would be, yeah, it's sine pi over 12, but you have to multiply that by 350 root 2. Did you distribute the number outside the parentheses?
Where's I?
There isn't.
Second decimal point.
Really?
Yeah.
I didn't know that. Yes, it's right. What do you know? Okay. I usually just use root or -1. What's happening? Didn't you guys already answer?
Yeah, we only answered the first one.
Yeah, we're just doing the product right now. You're good.
Why did the other one do?
You're amazing. Okay.
What is that?
I'm going to give you guys one more minute because some teams are already doing the next problem.
Are we going to do this?
Yes. You guys can take a little brain break.
Can you tell me if it's right?
Yes. Show me again.
Oh, I'm sorry.
Yes.
Yeah. It should be a like
whether or not they want to. That's hopefully where they're gonna go.
Are you going to go to the future pilots like showing up?
Are you in Radiance?
I didn't know about this. A future pilot showing of Springsteen.
On Thursday night, it's for future pilots.
I'm going to the preview.
Oh, that's that.
That's it? Okay.
With your kids?
No, I'm supervising, so I don't think I can bring my kids because I'm working. I missed that memo. Next year. There's a few years before they're my oldest one's in 6th grade, my younger one's in 5th grade. So the freshmen this year will be seniors when my older daughter is a freshman, yeah. All right, teams 1 and 2, you guys close? So there should be 2 numbers, a real number and an imaginary number.
Oh, there's a second number?
You gave me 2 numbers.
I gave you.
I'll give it to you. You're going to get it. Just make sure you put the I. Oh, so it's team 2, you guys close?
So it's 2 numbers.
I didn't know that she was
Okay. Are we not doing solution too? I did the same.
I got what she got.
Show me if you can add this. No worries, no worries.
All right, ladies.
Yes.
Yeah, I got one.
What's that?
Hold up. But like,
Oh, what is that? Like 470. Yeah. Well, it's just like, yeah. It's also
no, but like honestly, mine was close to dying for weeks.
Oh, I saw it.
All right, ladies, here is the answer.
Yeah, sorry.
Come on. Okay, so plug everything in. We've got 25 root 2 times 14 cosine of negative pi over 4 plus pi over 3 plus I sine negative pi over 4 plus pi over 3. Negative pi over 4 plus pi over 3 is pi over 12. This becomes 350 root 2. Distribute this to each term, and you're going to get 478.109 plus 128.109I. Any questions? You guys ready to try division? Let's do it. Okay, and team 5, you're done. The first number is right. The second number is not. Correct. No, it's the number is incorrect. Did you distribute? No, the number outside the parentheses. I think it's 25 root 2 over 14. You distribute that to both the cosine and the sine. Okay, so you do need to distribute because of the parentheses. You switched the I term, and the 2 numbers should be switched. The I should be on the other one. Yes. Good job. Oh, sorry. It's not right. I'm not sure what went wrong. What'd you get for your... Did you get negative 7 pi over 12? Okay. Then double check parentheses. There might be a parentheses that's misplaced. Yes. All right, I'm going to give you guys one more minute. One more minute. Team 4, you guys close? Yes. Hold on. Actually, show me again. Sorry. Sorry, the first number's right. How close would you be to figuring out the second number?
Well, we all got different answers. We have 3 possibilities.
Show me everything. That is a little concerning. It's all good. We're learning. Yes.
Okay.
I'm gonna guess that you didn't distribute the 25 root 2 over 14.
I did.
You did?
Yeah. Okay.
Maybe put a little less into your calculator at a time then.
Oh, that was the last step. Like I kept the decimal. So.
Okay, I don't know then. Okay.
Is the last,
Yes.
is the last digit 9 or 4? We wrote it.
On it. 9. All right, here's the answer, you guys. It is written on Post-its because I ran out of space. Hi everyone, if you're watching this on video, I didn't realize that it had stopped recording, but here is example number 1. Feel free to pause on any part that you need. And this is where we currently are. Okay, any questions on this part? Does anyone need a few more seconds to copy it down? Okay. All right, so example number 2, I'm going to jump back here real quick. We are going to be using this theorem for example number 2, okay? So z equals r cosine theta plus I sine theta. If you raise z to some power, it's the same as raising r to the n power and then multiplying theta by n inside each trig function. Okay, so I'm going to get you guys started on this one, and then I'll let you guys take it from there. This says, find 1 plus I root 3 cubed. So in this case, our z is going to be 1 plus I root 3. To find r, this is not absolute value. This is... This is the distance formula. So from here, you would need to figure out what your theta is using your real and imaginary part. And then plug it in. Do you guys feel like you could take it from here, or do you need a little more?
Wait, is that
Z equals, yeah, that's an equal sign. Z equals 1 plus, let me zoom in a bit. Do you feel like you got it from here, or do you need a little bit more before I let you guys take it? Yes. Yes. So the radius is going to be basically the distance formula. So this one is just, it's the Pythagorean theorem or the distance formula, depending on how you look at it. Yes. Yes. Well, no. Z is going to be 1 plus I root 3, and then we're going to find Z cubed. So if you look at the formula, the argument inside is your Z. And then whatever power you're raising it to, you're going to raise that. You're going to raise Z to that power. Okay, I'll give you guys a little bit more. So theta, this is 1. This is 1 plus I root 3. It has a radius of 2. Theta is pi over 3. Just so you're aware, this formula, it's not really something that you should have to memorize separately. I'm hoping everyone knows the Pythagorean theorem or distance formula. The Pythagorean theorem and the distance formula are the same formula. A squared plus b squared equals c squared. The distance formula is c equals the square root of a squared plus b squared. If you squared both sides, you get the Pythagorean theorem. It's the same. Yeah. Exactly. So in this case, we're trying to find the length of this line. We do that a squared plus b squared and then take the square root. It's the Pythagorean theorem. A squared plus b squared equals c squared. If you're solving for c, what do you do? Square root both sides, right? Yeah. Okay, you guys take it from here. You guys got this. One moment, please. No, sorry. Yes. So it's the ratio. You know how to graph this, right? Where is that on the unit circle? Yeah. If you were to divide each of these by 2, you would get 1 over 2 root 3 over 2, which is pi over 3. It's the same ratio. Yes. Always divide by 2. No. So you start with the unit circle, and then you can multiply by whatever number. If you multiply by 2, you'll get these. If you multiply by 3, you'll get something else. You can multiply by 4 or 5. So you should know the ratios. You should know that any ratio of 1 and root 3 is going to give you pi over 3. Any ratio. One moment. It's not right. I'm sorry. So what I'm trying to say is, no, you won't always do anything. You have to do whatever you need to do to find the ratio. Whatever you need to do. So I don't. Do you know how to find ratios, right? So like if you had 1 to 2, this is the same as 100 to 200. It's the same as pi to 2 pi. These are all the same ratio. This is all the ratio 1 to 2. So these ratios work for anything you're going to multiply them by. One moment, please. Sorry. Come on. So in this case, we're multiplying by 2. Because, and hopefully you can see that because the 1 and root 3 are there. I think if they have a ratio that appears on the unit circle, it's going to be obvious that it's on the unit circle. It's going to be something pretty clear. Yes? No.
And also, are we solving for Z?
I'm sorry?
Are we solving for Z?
You're solving for Z cubed. Great job. Don't show anyone. You're the only team to get it right so far.
It's cute. So you give us this.
In this case, it's cubed. As it says, find this.
Oh, it's this. So,
Yeah.
So that. So, one moment, please. You know that this is 1, right?
Yeah.
And you know that this is root 3. How do you find this? Yeah.
I see.
No, sorry.
We show you one.
Just give me the answer. The final answer will not have an I in it. I mean, you could write it with an I. You could write it with an I, but you can also write it without. That's correct.
What did you
Once you simplify it. All right, I'm going to give you guys 1 more minute, and then we'll go over it. Sure, I'll give you guys 2 more minutes. Now, I'll give you 90 seconds. 90 seconds, then we'll go over it. No, sorry. No, sorry.
that's not my answer.
Oh, okay.
Do you use both? What do you mean?
R cubed.
Oh, yeah. Okay. I was just writing down that thing. What did you want?
I think it's right. I'm going to give it to you. Get a new marker.
Wait, just come on. Give me like 1 second.
Well, you guys have a minute and 2 seconds.
Oh, perfect. That's all I need.
Yes.
So the one represents A, X, and the 0 represents Y.
Yeah, just as long as you know it's not X and Y, but for graphing purposes, yes.
So when you square it, it's like
Yeah, so you got
When you square the Y part, you get 3.
because how about I?
Why are you squaring it? Oh, this one here? The root 3 squared is 3. So 1 plus 3 is 4. The square root of 4 is 2. No, sorry.
So we're not.
Did you multiply the angles by 3?
So now it's square root.
So what we're doing is, we know, imagine a right triangle. This is 1. This is root 3. How do you find this? It's going to be a squared plus b squared, and then find the square root. That's what the absolute, it's not an absolute value, it's distance. All right, any other answers? No, sorry. Anybody else? Let me see.
No, she's checking my. I'm checking her thing. This is not working.
But don't be helping right here.
You need one more. I don't know.
All right.
Wait, go on.
Let me see.
You need one more parentheses in your calculator. Yeah. Don't worry.
You guys got it? You guys close? No, sorry. We'll go over this one. Okay, here is the answer. Okay, so z is going to be this. Z cubed is 2 cubed, and then you're going to multiply each of these angles by 3. So we're going to have 8 cosine pi, I sine pi. Cosine of pi is -1. Sine of pi is 0. So -8 is the answer. If you had given me -8 plus 0i, I would have also accepted that. That's the formula.
Can you like go up a little bit?
Yep. Yes.
Why does it go from like that to that? Why does it do that?
There's a report that we're not gonna. So this is showing you that Z inside here, and if you raise the n power, yeah, just comes out. Yes.
Why would you discuss?
I got the first step right.
They are both in HTTP. You don't have to use it. There might be a problem.
That's why I got negative 2.
Wait, why did you
Well, it's one of the limitations of the calculator.
why did you put 2 to the third power?
That's the formula.
It says R.
Cook, aren't you in front of this?
Hold on, let me freeze this.
Wait, Miss Lamar, where's the sign?
Yeah, because why would I take it straight?
What sign of pi?
No, you like the second step.
Because it's
Oh, it should be there. I'll fix it. That was me writing fast and trying to fit it.
And then R is just 2. No, because I have
Okay.
Alright, so this is Z.
yeah.
And if you raise that to the n power, it equals this. So Z to the n power, and then you go sine Z was.
Oh, right.
That 3 cancels. That won't always be
You just don't put signs.
I was writing fast and I missed it.
Okay, but it should.
I have added it. Alright, ladies, let me correct this. I was writing fast and I missed the sign right there. Everything's correct, I just forgot to write sign here. There we go. Okay, anyone else need some help?
And then you have the 8 sign. Times cosine
Well, I did cosine pi and sine pi because those are only answers. Cosine
Yeah.
pi is -1, sine pi is 0.
Yeah, so that was you just pop it on.
Yeah, it was easier to do that, and then I multiplied by e. But again, you could write -8 plus 0 I. That's the formula. I'll be right there. Oh.
It's just because, like, sine of pi is yeah. It's just not showing that Z equals. I don't know. And then we raise our hand power. There might be
Anyone else have any questions? How's everyone feeling? You feeling okay? We have one more example problem. I think we're going to make it. Knock on wood. Okay, I'll get you guys started on this one as well. Here is example number 3. Find all the cube roots of -1 and plot them. Okay, so, question. If you were to find the cube root of -1, like if you just would say, hey, find the cube root of -1, what is that? Yeah, sit down, Michaela. Okay, so let's talk about all right. So the square root of -1 is I. The cube root of -1, you need to think of a number that you multiply 3 times by itself and you get -1. Yeah. It's not 1. -1, thank you. People were saying no. Okay. The cube root of 1 is 1. Cube root of -1 is 1. But we know from the fundamental theorem of algebra that there are 2 more roots in there. When you find the cube root of something, there are going to be 3 roots. Using complex numbers, using the third theorem, we can actually find the other 2. So, first thing I'm going to do, I'm going to write this in complex form. So -1 is going to be -1 plus 0i. And I kind of gave away the angle, so I might as well just show it. Let's see here. There we go. -1 plus 0i, that gives us pi as the angle. I'll give you guys a little more. Okay, so the formula on the front of the page is this. And because we're finding 3 roots, we need to find this for k equals 0, k equals 1, and k equals 2. You plug that in, and that's how you get the 3 roots. You guys can take it from here?
Yeah.
Okay. Yes.
Whenever this is asked, we're always going to plug in 0, 1, 2.
It depends on how many roots it's asking. So on the front of the page, let's find the wording, it says where k is 0, 1, 2, ... n minus 1. So if you're finding the cube root, it's going to be 0, 1, 2. If you're finding the 5th root, 0, 1, 2, 3, 4. It's always going to end 1 less than the root. Mm-hmm. Yep, sure. If you do this, you're going to find that -1 is one of these. I think it's the middle one. Yes. How did I find the angle? Well, where is -1 and 0i? It's right here, right? And what angle is that? Hey ladies, one thing I didn't go over. What is arc in this case? What's the length of that line? Well, it's 1, right? Because the distance from 0 is always going to be 1.
Are these going to be like numbers, or are they going to be?
Give me exact answers.
Oh, what?
Give me exact answers. Use the unit circle. Yes.
Oh. What is this? Use the unit circle. Simplify, and then find that value. All of them are going to be things on a unit circle. If you have cosine pi over 3, that's on the unit circle.
Yeah, so you solve for cosine pi over 3.
Yeah. Yes.
I got negative 1/3 for all my cosines.
So, erase your x values. Just give me z1, z2, and z3. So they're not going to be coordinates. So you wrote them in coordinate form. All correct. Great job. Yes. That's correct. You need the I after the last term.
Oh, like to.
Yes.
I don't know.
Let me try that again. I plugged in pi over 3.
No, I didn't.
Okay, but I plugged in and what we got is
Where?
you see?
Yeah. I got
Yes. Sorry, guys. I lost track of time. We were having so much fun. So they're not exact answers. Here are the answers, and here is the graph. There you go. All right, if you need to head out, I am going to post this video. You can just fast forward to the end and copy it down then. Okay. Okay. I knew it. I have every confidence that given more time, you guys all would have gotten it. Like, you guys were all on the right track. I mean, you guys got it right, but it wasn't in the exact form. You guys, I think, had one. You had, yeah, you got the point. You guys were asking questions that made me feel that you guys were on the right track as well. So, you guys did great. All right, you guys, yes. Yes.
So in here, this is the formula you started with. That would just be 0, so then I cancel out. And then that's how you get left with pi over 3. And then,
So you plug in 1.
you just look on the integral for cosine pi over 3 to sine pi over 3. It's more simple than
You're good, you're good. Remember, x is cosine, y is sine.